Alright, so today we'll be talking about the normal distribution. Now, we've been talking a lot about data sets this entire chapter and just setting them up and working with them. Now we're going to be talking about data sets that's so large we can't figure out what's going on with them. We can't see them each individually, but we can't calculate them as easily, but once we get the calculations, they turn into these really nice things, and we call them the normal curves. And this is one of the best normal curves I've seen, and it actually gives a lot of really cool stuff with it. So the bell curve is just shaped like this. It's a very normal curve. Now the cool thing about it is that the mean, the median, and the mode are all the same up here. Okay. Now, if you notice, they also have sigmas down here. And if we just talked about standard deviations, these are the standard deviations off of the actual normal distribution curve. Okay. Now, they have these things called z-scores, and we'll talk about those in a second. And they have cumulative percentages and standard deviations down here, and we'll talk about those more in a little bit. But I just want to show you what the shape of the actual normal bell curve is. Okay, now the bell curve, there has been a recent proponent of the double modal, which would have two of these curves, one over here, and it would still be normal distribution type of stuff. So that's starting to pop up. It's starting to become more popular, especially with test scores, with a lot of kids not doing as well and a lot of kids doing really well. It tends to pop up when you're dealing with test scores. But if we're talking about distributions of the size lengths or the sizes of people's shoes or whatnot, you know, the bell curve definitely does show up, and it's a really nice one that actually works out. Okay, now normally these numbers, these z-score numbers, would not exist. What you would see is the actual numbers of the data set. Okay, now here's the cool thing about the normal distribution. It is a 50-50 thing. Since the median is in the middle, okay, 50% of the data is over here and 50% is over here. Now, between the median and the first standard deviation above it, okay, that is actually 34.1% of your data is actually in this little box. And same thing here, because the normal distribution curve is actually symmetrical, and as you can see, it has this nice symmetry flowing off to the sides. If I slid down on this side, it would be the same as sliding down on that side. Okay. All right, so here's the standard deviations. Now, if you want to take time to go ahead and mark this up, please do so now. I got it from the wonderful website of mathisfun.com, the normal distribution page, and it's a bit of a ways down, but it really helps out. Okay. Now, cumulative percentages work up this way, and you can actually find what range of answers you have. So if you find that you are working with something in standard deviation of 2.5, you're probably working between the 99 and the 99.9 percentile range, and just working with that. So these percentiles line up not exactly, but very darn close to what we actually need, and it's some really cool stuff that you can actually have. Okay. All right, now taking a look at this stuff, it might look really imposing and everything, but you can actually find the data that you want to actually work with. Okay. Okay, so now really looking at this really kind of fast too. I did not talk too much about it, but usually between the plus or minus one standard deviation range is going to be about, I believe that's 68.2%. Between the two plus or minus 2 percentile range is going to be another 13.6. It's going to be about the 95 percentile range, and between 3 standard deviations is about 99.7. This one's going to have a little bit off, but usually if you go with those numbers, it will help out tremendously when you're actually working with it. It's actually kind of cool how it does work. Okay. Now you can also look at these percentages down here and subtract them, these cumulative percentages, and you would find how much data is actually located in there. It's actually really kind of cool how it works. Okay. All right. A lot of this stuff you're going to be using the data to actually calculate and just work with to find out like how much everything's going to be. just remember your percentiles will be these cumulative percentages as you work down here. So if you're looking at you're in the 99th percentile, you're about in the you're about 2¼ standard deviations above the norm is what that is. Okay. All right. Whereas if you are in the 95th percentile, you're about a little over 1½ standard deviations above the norm. Okay. All right. That is it for normal distributions. I'll talk to you later. Bye.